And welcome back to Null Zero Labs. In last week's video, we built a simple network to test and show off the everyday tasks that you might have to perform on a Palo Alto firewall. In this week's video, we're going to dive in and add a second site and connect a VPN tunnel between the two sites and demonstrate, again, adding some policies and rules to allow that remote site access to the server VLAN. So let's jump into the lab. Here we are in the lab. And as we can remember from last week's video, we configured this portion to allow the desktops to access the server subnet and to allow our servers in the server subnet access to the DMZ server, obviously allowing certain ports and services only, and to allow both the VLANs access to our fake internet environment and accessing our online www server. Now, to save us from repeating that step again for site A over here, I've pre-configured site A to the point where it's got internet access, it can reach the WW server, it can ping the gateway of the Palo Alto firewall, etc. So the inside host behind site A can ping the public side. So to demonstrate that, let's connect to the host in the internal network of site A, and we'll test ping to the www host here, which is this one here. And we can see that, like before, this host is being NATed out onto the internet, and we have policies that allow it to access the internet, and the pings are going through. Likewise, if we jump onto one of the desktops in the HQ side, and again, the desktop, and we log in, and we can keep these open. And we open a terminal on here. Ubuntu always looks so pretty. If we ping 203.0.113.66, again, we can see the HQ side has access to our fake internet area. So that's all working. So our two sites have internet access. The next step is to join them. So let's start on the remote side. And this is site A's firewall. So we're going to take note of a few things here. We can see that it's got a public IP address on its outside interface. It's got its inside interface. It's got a policy allowing it to access the internet. It has its outbound NAT. And likewise over on the HQ side, we've got a similar scenario, but we've got more interfaces configured. So let's start on this side. And what we're going to do is we're going to jump to the networking area, and we're going to start with a phase 1. We're going to click on add. We're going to call this, as this is the remote side, we're going to call this HQ gateway. We're going to use IKE version 2. We're going to use the outside interface and its public IP address. We're going to connect to the HQ's public IP, which was 203.0.113.2. As remember, we've got a NAT pool for .3, and that's going directly to our public server, so that's not being used directly on our firewall interface. So we're going to use .2. So we are going to go to 203.0.113.2. we are going to create a pre-share key. Remember, you're going to want this to be long. You should generate it, but we will use a simple one for here. And remember, this has to match both sides. And we will do a local identification of our local IP address, which is 192.0.2.2. And we are expecting the peer to give us the same IP. Under the advanced section, we're not going to enable any of the passive mode. We can allow both sides to dial up towards each other, depending on which way traffic is flowing. We're not going to worry about NAT transversal at the moment. So we will just set our crypto profile of GMC 256. And that should add that. We can see what our profiles are down here under the IPsec and the crypto profiles. So we can see we're going to use this one. Remember, both sides need to match. So for our phase 1, we're going to be using AES 256 CBC, and we're going to use a SHA-384 authentication with a DH group of 20 and a lifetime key of 8 hours. So now we've got our phase 1 configured for this side. Let's configure our phase 2 or our tunnel. So we're going to come up here to our IPsec tunnels and we're going to add a tunnel. We'll call this HQ ton. We're going to create a new tunnel interface. Call this tunnel 1. Going to make it part of our default virtual router. We can create a security group for it. We can call it HQ VPN. We're not going to assign an IP address to it because we're not going to be doing any routing protocols. We're going to assign a standard static route to say send everything down the tunnel interface as the next hop rather than assigning an IP address. So if you wanted to run things like routing protocols between the two firewalls, or you wanted to do specific pings to the endpoint of the tunnel to know that it's up or down, then you'll assign an IP address. But in this case, we're just creating a simple point-to-point tunnel, so we're not going to bother with that. So because of that, guys, we don't need to bother putting a management profile because we're not going to be able to ping the other side. So we're going to create that tunnel, and we're going to say that it's going to use the HQ gateway. And again, we're going to use the best profile that we can support. And we'll hit on OK. So again, now if we look at what we're trying to achieve, we want this host to be able to talk to this subnet here. So what we're going to say is we're going to say that this subnet is available via that tunnel interface. So we're going to add some static routes now saying that 192.168.100.0/24 is going to be available via that tunnel. So if we jump up to our virtual routers, we're going to add a static route and we're going to say HQ servers. And we're going to be looking for 192.168.100.0/24. And it's going to be available via tunnel 1. We're not going to give it a next hop IP address. And we're going to hit add. So now we're saying if you want to reach this, send it down the tunnel. And finally, if my memory serves me correct, we're going to add a policy now, a security policy. And we're going to say site A to HQ. And we're going to say if it's coming from inside with an address of 192.168.100.0/24, I think it's 200.0/24. 192.168.200.0/24, yes. And we're going to say its destination, if it's going to the HQ VPN, to a destination address of 192.168.100.0/24. And we will allow all applications to go through. Obviously, you may have specific security requirements where you'll want to lock it down based on application or a server or a service. But in this instance, we're going to allow everything from site A to access anything inside the server network. So we're going to hit on OK. So this will allow us to reach across and access the server network. Obviously, like I said before, there is no reason technically for us to add one allowing it to come back, because the server shouldn't have any reason to talk to the client network over in site A. The site A will want to talk to the server, and because it's a stateful firewall, the firewall should allow the communication. So we're going to test by just adding the rule to say, hey, if you're in site A, you want to touch it, you're going to allow it. It can go on its way. The firewall is stateful. It will allow the return traffic path. So I'm just going to move that before the internet rule. And I'm going to hit commit on site A's firewall. So whilst that's happening, let's jump over onto the HQ side, this one over here. And so here we're going to set up again a gateway for this firewall. And we're going to allow traffic coming from this zone to go. We're going to allow traffic coming from the firewall to come into this zone. So what we'll do is we're going to now set up a gateway, create a tunnel, add a route to say that this subnet is available via the tunnel so it knows how to get back. And then we're going to add a policy to say if it's coming from this tunnel, it can then access the zone. So again, we're going to jump down to our phase one, which is our IKE gateway. And we'll call this site A gateway. Again, we're going to use IKEv2. The interface is going to be our outside interface. We're going to use that public IP address. Our peer address is going to be this device's public IP, which is 192.0.2.2. Again, we're going to put a pre-share key, which was and we'll soon find out if I got those right. The tunnel doesn't come up. Our local authentication is going to be local identification is going to be our public IP. And we're expecting the peer to identify itself with its public IP. And again, the crypto map we're going to use is GMC 256. We're going to OK that. So that's our gateway. We then want our tunnel. So that's site. Done. Going to create a new tunnel interface. It's going to be part of the default virtual routing. Again, we've got no reason to put an IP address on here. We will create a security zone and we'll call it site A VPN. And we'll hit OK. We will say it's part of site A gateway, and we are going to use 256 crypto map, and that will be it. Again, virtual routing. We're going to add a static route and say site A 192.168.200.0/24 is available. Oh, select the right one. Site A, 192.168.200.0/24 is available via our tunnel interface. We're not using IP addresses, so none. And we'll say OK. Finally, we'll add a policy. And we will say site A to servers. So if it's coming from the site A VPN tunnel interface with a source address of 192.168.200.0/24, we are going to allow it to go to the server subnet, which obviously has a 192.168.100.0/24, and we're going to allow all traffic, and we will hit commit. Okay, so that's committed successfully. So now let's go over to our client machine in site A. Which is, yes, it is that one. And we're going to see if we can send some ping traffic over to 192.168.100.2. See if we get anything. Okay, we're not getting anything. So let's have a look and see what we're getting on the firewall. Let's just do a refresh. Okay. I think I might have set the password wrong, so we do have to double check that for the pre-shared key. So let's double check that. That was under tunnel interfaces. Where is pre-shared? No. Phase 1. What I'm looking for. I think I put the password wrong. Phase 1's not coming up. Still on OK. Let's commit that. Let's wait for that to commit. Whilst that's committing, let's just have a quick look at the logs on this side, see if we can see anything. Be under system. Right, so the negotiation was failing, authentication failure. So yeah, I think I mistyped the password for the phase 1. So now that I've fixed that, we should see the phase 1 negotiation complete successfully. There we go, commit successful. So we'll close that. Now let's jump back over to this log. Let's refresh it. Let's jump to IPsec tunnels. Don't want to do that. Refresh. Okay, so it's initiating now. Okay, we're getting a response now. Okay, so let's refresh this. We should see these turn green. Let's check on the remote side. Go to networks, IPsec tunnels. There we go. So on the HQ side, we're now seeing the tunnel is up and green. And we're seeing phase 1 is acting as the responder because obviously the traffic has come from site A's side. So the HQ's firewall has responded to the request to for the tunnel to be created. and the HQ one has allowed that and responded to site A's tunnel request, and the tunnel is formed. And we can see phase 1 is up and operational, and then obviously because we have the tunnel info as green over here, we know that phase 2 is functional. So now if I look over this side on site A side, again under the IPsec tunnels, we can see phase 2 is happy because the tunnel info is green, and we can see phase 1 is also green and it acted as the initiator. So perfect. And then if we come over to our box, which is over here in site A, we can see that it can ping and send traffic to server 2. Let's see if it can reach let's see if we can SSH null 0 labs at 192.168.100.2. There we go. We can see we have SSH traffic going across. So let's have a look at the monitor tab. And we can see the easiest way to do this if we go to policies. If we look at the rule, site A is a HQ, and we click on the log viewer rule, we can then see all traffic now coming from the inside zone, going to the VPN tunnel zone, going to this source. We can see all the pings going across. And once it refreshes, we will see the SSH traffic going across also. Let's see if we can access the web server on that server. So if I exit the SSH session, start X on this one. And we bring up Firefox. Go. And we'll go to 192.168.100.1 because there is also a web server on there, and that is working. Now if I hit refresh on the monitor tab, we can see the SSH going across from site A to the server in the HQ. But what we should see is if we jump onto one of the servers, we should not be able to initiate traffic back to that server. So if I log on here, null 0 labs, test 1, 2, 3, I try and ping back to 192.168.200. I think that's 1. We can see nothing's happening. So the servers cannot initiate traffic back to site A, which is great for security because the servers have got no reason to directly try and access the clients. The clients are trying to access the servers. The firewalls know that if their client initiates traffic to reach the server, it knows that there should be a return pathway, and the pathway allows the data to come back. So there we go. We have successfully created a VPN tunnel between site A and the HQ side, and our client in site A can reach our server subnet in the HQ office, and the server subnet in the HQ office is prevented by the firewall policies from trying to access clients back in that zone. So if we look at the monitor on the HQ side and we hit refresh, not only can we see that the tunnel succeeded, now we can see the phase 1 succeeded, whereas before we saw that there was a failure because of a password issue. If we now go to the traffic and we filter it based upon the policy, so let's go to policies actually. There's that policy, site A to servers, log viewer, and we can see that coming from the VPN tunnel to the server zone, there we go, we can see on the HQ side that the client accessed the web server on server 1. We can see it SSH'd into server 2. We can see it was pinging server 2. So if we go back to the monitor tab, and then we try and force server 2, just to demonstrate that the firewall will deny it. If we SSH to 192.168.200.1, and we look at the firewall, well, the easiest way to do that will be to jump to the one on the end here, do log view, and there we go. We can see the deny. So there you go. You can see from the server zone, it tried to access site A, and it tried to reach this destination, port 22, that we know is SSH, and we can see that we prevented that traffic flow from happening. So the firewall did its job. The policies that we created under the policy section are doing what they're meant to do. They're allowing site A to access the internet. They're allowing site A to access the server zone in the HQ. And then on the HQ side, we can see that we've got our rules that are allowing our inter-zone traffic. We're also allowing our zones to the internet, but we're also allowing site A under its rule to access the server zone. So there we go. Short video this week, and I hope you can see just how easy that is to get secure site-to-site traffic between multiple sites to a central location. You could easily have 10, 20 other offices all VPNing back to this firewall to access a server or a resource securely inside this server zone. And then you can allow not only your office desktop clients on here, and you can also allow your remote sites to access the same resources securely over the internet in a cost-effective manner. You can also allow remote access to the firewall for users and devices that are what we would call road warriors. They can VPN in directly to the firewall without requiring a hardware device, using software on their laptop, and they too would then be able to initiate a similar connection to the firewall to access a resource in a shared zone. So there you go. I hope you found this short video useful. Going to come up with some ideas for the next one whilst I'm laying on my sun lounger on holiday. And when I come back, we will get deep diving into the lab with something new and exciting. So until then, like and subscribe, and I will see you next time.